All right, so we are welcome back to class, and this is module 4 of the product owner training. Just a quick recap of where we were in module 3. In module 3, we looked at the essential roles of the product owner, and we discussed first about the product owner in the sprint. That's what the product owner does in the sprint. From where we moved over to talk about the product vision, and we looked at a couple of other stuffs under the product vision. From where we moved over to the artifact, looking at the first Scrum artifact, the product backlog, then the second Scrum artifact, the sprint backlog, and the third Scrum artifact, the product increment. From where we now discussed, which was the last topic in that module, on what goes into the product backlog. So those were the things we looked at in the third module of the product owner. In this module, the fourth module, we would start by looking at some other areas or some other capacities or skills or responsibilities of the product owner. So we'll talk about capacity planning and estimation. We would also be looking at the backlog. We'll look at prioritization, story mapping, and a few other things, which would include the product owner and the stakeholders, on and on. All right, so let's jump right into the class to see what we have to discuss about today in module 4, lesson 1. Just a few minutes, please. Just checking. All right, so let's dive into it. I would start the first lesson of module 4 on capacity planning and estimation. What is capacity planning and estimation? We mentioned that now we understand what a team is, what a Scrum team is, comprising the product owner, the Scrum Master, and the development or the developers. And and we know what a sprint is. It's either called sprint or iteration. That is the duration of work, right? So when we say we are running 2 weekly sprints or 4 weekly sprints or 1 weekly sprint or 3 weekly sprints, as we decide, how do we then plan for those? So those are some of those areas we would be looking at in this class. Let's assume we have 7-member team. 7-member team has different skill sets. Then we need to plan based on their capacity. We need to estimate also based on their availability and what they can deliver. And that is what we want to look at. It could be a long lesson, so let's deep further into this. So capacity planning. Where's my pen? Okay. Let me see if I can get a better pen. I'm not really liking that pen that I've been using. Okay, let's just stick to this. All right, so capacity planning. When we look at what we have on the screen here, we'll say input for sprint planning. We are planning for a sprint but one of our considerations is to plan for the capacity of the team. In the illustration we're using, we have a 7 team member, 7 individuals in a team, right? That is inclusive of the Scrum Master and the product owner. That means we have 5 developers left. Now, the 5 developers are the ones to carry out the actual work of development. They are responsible to carry out the actual work of development. But we would need to plan how they work in the sprints. We need to plan how they work in the sprints. So that's where capacity planning comes to play. Input for sprint planning. So the capacity of a team is the available time that the team has to complete an amount of work. To complete an amount of work. So the capacity is the available time a team has to complete the amount of work. That is the capacity. The available time a team has to complete an amount of work. So let's say this is a work to be carried out, right? Let's say this is a big load. And so how long will it take us to move this load from point A to point B? Let's assume these are stacked bags of cement. How long will it take us to move it? What is the total number of the team force? How many laborers will be carrying those cement from point A to point B? What can they carry per time? How long would they take per time? All those will come to play to form that team's capacity. So let's assume we have, in this illustration, in just this illustration alone, we have 2 men as laborers that will carry 100 bags of cement. How long will it take them to carry this? If these 2 men could carry, let's say we are not overworking them, but let's assume they could carry 5 bags per time. You know, those folks could be quite muscular. So they could carry 5 bags per time. That means those two will be carrying 10 bags per period of time, right? 10 bags per period of time. So by the time they go 10 times, they would have finished carrying the entire 100 bags. So how long will it take them for each trip, right? Man 1 carries 5 bags, man 2 carries 5 bags, and it will take him to cover a distance or in 5 minutes, right? It depends on what we're looking at. That 5 minutes, are they walking together? Are they moving? Both men, are they moving from point A at the same time to get to point B at the same time, or they are moving one after the other? Those will be some other consideration. But the idea we'll paint in here is that the capacity of that team, so in 5 minutes, they could deliver 10 bags. So if they would go 10 times, they would deliver 100 bags in total, meaning 5 minutes times those 10 times, meaning in 50 minutes, those 2 would have carried 100 bags. So this 2-man team, the capacity the 2 men have is carrying 100 bags in 50 minutes. That's their team capacity. Just a brief understanding of laying the foundation for this. So planning the team's capacity involves so many considerations, including the team stability. What do we mean by team stability? We have just two men, and so we're running a sprint. Let's now expand that conversation further, where we have, instead of just 1 day work, we have 500 bags to be moved. Let's assume we have 500 bags to be moved. But this team has other commitments at other places. So they could only spare 50 to 1 hour with this particular task in a day. Meaning they could only move 100 bags of cement in a day. Telling us that they would be able to move the 500 bags in 5 days total. I hope we can follow that analogy. If two men, each carrying 5 bags in 5 minutes, would move from point A to point B, then the two of them would move 10 bags in 5 minutes, and it will take them 10 trips to cover 100 bags, because the two of them would carry 10 bags. And so we will now have, let's assume they move at the same time. So we now have 5 minutes times 10 trips will give us the total time of 50 minutes. We now expanded that conversation to say the team has just 50 minutes to 1 hour to work on this task alone. They have their commitments at other places also. And the total work they want to carry out is 500 bags. So invariably, they are looking forward to moving the 500 bags in 5 days. Let's say Mondays through Friday. What happens to that capacity when on day 2, one person shows up at work? That means the team stability has been impacted. So what the team would be able to do would be lower, right? So they'll be only able to do half the work, because 2 men had now been reduced to 1 man. That is talking about the team stability, right? Or let's say for whatever reason you get to site today and you realize that your project manager left a note at close of work yesterday that he had deployed one of your 2 laborers to another task. That means your team stability had been impacted. So what they can deliver will drop. So you need to consider that when you are planning. That is where the question comes, who is available in this sprint? You know, we're planning for the sprint. Capacity planning happens in Scrum at the beginning of the sprint. Capacity planning happens in Scrum at the beginning of the sprint. So the team would come together to say, I would only be available 3 times in the week because I have a doctor's appointment, or my son has a football match that I need to attend. Another person comes back to say, sorry, I will not be able to be at joining or any effort all through this week because I have a planned vacation and I'm traveling out. I wouldn't be available. So it could be any reason that could impact the stability of the team. So while planning the sprints, we want to find out who is available, who is not available. Then also want to consider the total story point. We'll see this when we go further in just a bit. The story point, we've explained that from the 3rd module. The story point has to do with an estimate. And story point is different from hours or different from time. We will see that in another slide as we go further. Right? So let's just put in mind that the story point is one of another thing that could be considered. We could assume that each day's work for these two men equates to 2 points based on different indices, which could be the volume of work, the certainty, the complexity, what again? And the rest, the risk, and all of the factors, right? Then, of course, the duration of work is considered, just as we've seen here. Then the actual time to work is also considered. Then available and non-available time. We'll see this availability relating more to the stability of the team. I used availability to explain stability. There could be other factors that could impact on stability, where suddenly one of the team members got another job in another place, so that stability is affected, or when the project manager or leadership decides to deploy someone out of that team, or sometimes also bring a new man into that team. That will also impact on the delivery of the team. Calendar time, actual time, and ideal time. We'll be expanding on those as we go forward. But let's just know that they are estimation. Let's come to this. A quick explanation of this is the velocity. We know what velocity is now. We've looked at those in previous classes. And the velocity is the total capacity at an average total capacity a team delivers on sprint in, sprint out. There's what we call yesterday's weather. We've explained that in some of the previous classes. Yesterday's weather is total story points, or what total capacity did the team deliver in previous sprints. So where we know that on an average the team commits and completes about 65 story points in each sprint, then those 65 story points would equate to the team's velocity. That means their capacity is 65 story points. So where you have stories over 70 or 70 and above, you can be rest assured that they would be able to complete about 65 of those total story points. So we could see velocity and story point working hand in hand. The story point is the estimation of what needs to be done. How long will it take us to deliver that particular piece of work? We'll expand on this in the next few slides. Then also we can see availability, team available time and individual available time. Individual available time impacts on team's availability. When one person drops off or by any reason is not available, that would impact on the total time that the team has to deliver that piece of work. So all this would be considered when the team is planning the capacity. So during the sprint planning session, the product owner would want to have some idea, would check what the team capacity is, and is asking, who is in, who is out, what capacity can we deliver. The Scrum Master is also supporting the product owner to ensure that all these capacity considerations are checked before we begin to measure the volume of work to the team to deliver in that sprint. So that's what capacity planning is all about. The next slide, please. Yep. So we can see I've made emphasis time and again in the previous classes that estimation is at best just for planning. Estimation is at best just for planning. Why? Because an estimation, which is for planning, is always different from the actual. Let's look at this picture for one moment. While you're planning, this young man, okay, we can say he's a young man because of his okay, never mind. So this young man assumes that he is to embark on a journey from point A to point B. And the assumption is that the journey would be smooth, right? Imagine back in the days you want to travel from one point to another. I would not want to mention a particular location, and you had in mind that, oh, it will be a smooth ride. Possibly you have to travel by rail, that's going by train, and you envisage that the journey will be smooth. Some couple of days I needed to travel back from my place of work, and I had to, it's a two, how do we call it, two change trip, whereby I would be jumping from one train to another train, not jumping, literally jumping. I would need to alight from one train at a particular station and join another train. So I was coming from my place of work, and the journey was expected to be smooth. My period of interchange was meant to be 9 minutes. So in 9 minutes, one train is meant to arrive, and I'm meant to get down and join another train. Unfortunately, that train had a delay as we were coming. The first train had some delays on the way, and the delay was because there were some local train on the track. So the intertrain could not move as fast as it wanted to, because there was some local train on the track. So we arrived 5 minutes late. I was quite fortunate that I still had 4 minutes to jump down and jump on the next train. Not jump. I believe you understand what I'm saying, right? Perhaps with had longer delays, I would have missed that next train, right? So that's what happens on the journey too. You envisage that the journey will be smooth, but when you embark on the journey, you suddenly realize that there are some points you will need to go down and face some obstacles, and you need to climb up, and you need to use a bridge, and you need to climb up. At a point, you need to carry your bicycle into a river to go across, or if you are brave enough, you want to carry your bicycle and move on the rope, and on and on and on. You get to a place, you need to fall into a valley before you climb up a step while it's raining, meaning it could be slippery until you get to your destination. This destination here is the same as the destination here, but we can see the difference in your plan and the reality. How this play out on the field is that developers would commit to a particular task, and in the course of their delivery, they would encounter different challenges, they will encounter different problems, dependencies, blockers, and the rest. And that, of course, is why you need a scrum master to be supporting the team to deliver. So in all, note that your plan is always different, or mostly always different, from the actual. Yes, you need an estimate, which is at best your plan, but you also want to calculate what your reality is at the end of the day. So these are some of the factors you consider: the effort that may be required to build it, the complexity of that piece of work. So all these are factors that you need to consider: number of pieces, size of pieces, then of course the unknowns, the hands-off. Hands-off means the point of exchange, and that happens mostly between the developer and the tester. time of exchange, which would also impact on that delivery. Then dependencies also. Let's go further. We have some other grounds to cover. All right. So in this slide, we would see that the story point is different from calculating by hours. In story points helps determine team velocity month and hour. It provides a consistent measure of team output. It's quick to use once a reference story is established, and points per sprint. We will be looking at this more when we get to the practicals. We'll be able to expand further on it, but I won't take so much time here so that we can focus more on it. But just note that story point, we'll see that in the next slide also, that story point is calculating or estimating a story point is different from estimating in R. When we estimate in R, we want to look at how long in time it will take. But story point is looking at the effort in relation to what you have done in the previous. Yes, again, that video I shared earlier expatiated on the two also, so you may want to also check that up. But again, when we get to the practical, we will look at this further. Yeah, so let's look at this quickly. This would explain the previous class. This picture here would explain what we have here. So here, let's assume we have two different sprints. This is sprint Y and this is sprint Z. And we have total number of work hour is 80 hours. And the team members for both are 6. 60 members here, 60 members here. And they both have 80 hours to work. 10 working hours daily and 80 hours in total. So let's put it to mind that they have 80 hours in the sprint, right? 80 hours make a sprint. So in total, the all 6 developers multiplied by the 80 hours will give us 480 total time of work. That's why we have 480 here and we have 480 here. So the total available time for them to work is 480 hours. However, in sprint Y, the team committed to 93 story points and completed 80 story points. In team Z, they committed to 110 story points and completed 107 story points. Story point is a relative estimation, looking at what we've done previously, which is closer to it. That's what story point focuses on. So in sprint Y, a team completed 80 points. In sprint Z, a team completed 107 story points. So how long will it take them to deliver one story? On sprint Y, it took them 6 hours to deliver one story point. And that is when we divided 480 by 80 that they completed. 480 total hours available divided by 80 total points they completed gave us 6 hours of completing 1 point. We'll see from here the same 480 hours, they used it to complete 107 points. So 480 hours divided by 107 story points here in sprint Z gave 4.5 hours for 1 story point. So that's just pointing to us that story point is different from timing. Story point is relative, based on what a team had done previously. So one of the differences, or one of the reasons for this, could be that in this sprint they worked on some stories that are new to them, but in this sprint they now became more familiar with the story, so they were able to deliver more on it, right? So but what you need to note is that story point is different from um, estimation in time. When we get to the practicals, we would demonstrate it in the course of the sprint. The next slide, please. So our estimation, just as I said, is in relative terms. This is what we call T-shirt sizing. T-shirt sizing, and I believe we are all familiar with this. All of us that go out to shop, we would know that shirts, for instance, come in different sizes: extra small, small, medium, large, extra large. So in this, we can relate a piece of work to another piece of work. Let's say, for instance, we are familiar with a piece of work that is small. A piece of work that is small, we are familiar with it. Now, another piece of work drops. We now want to find out, in relative comparison, how big is the new work that needs to be done compared to a small work that needs to be done. If we use that previous illustration that I mentioned, where two laborers were able to carry 100 bags of cement in 50 minutes. So where we suddenly find out that we have 1,000 bags of cement to carry within the same duration of distance, we can now relatively say, if two men carried 100 bags in 50 minutes, how long will it take them to carry 1,000 bags? So all things being equal, what had changed is the total number of bags. The number of men had remained constant. So we would know that it will take them times 10 the time to deliver this. So we could have the number of men not changed. We could also have the number of men changed. So let's assume we have 4 men instead of 2. At equal capacity per man, they should, I use the word should, advisably should, they should deliver 100 bags in half the time. It does not, mind you, we are only estimating. It does not mean actual. We are using estimation for forecast as a plan. Okay? So that's what relative t-shirt sizing is about. In the next slide is where we now put value in points. This is what we mean by story points. We add it to the sizing, the t-shirt sizing we saw earlier. In the earlier one, we saw extra small, small, medium, large, extra large. Now we've added extra extra small and extra extra large. So let's say extra extra small, we add a point of 1, extra small point of 2, small point of 3, medium point of 5, large point of 8, extra large point of 13, and extra extra large point of 21. The question you want to ask is, how did we arrive at this number? This numbering model is called Fibonacci sequence. Fibonacci sequence. You may want to write that down if you are interested in finding out how Fibonacci sequence came to be. You could take some time to find out about that. But all you need to know is that this is what we call Fibonacci sequence. Our Fibonacci sequence is calculated is the addition of the last two numbers make up the next number. 1 plus 2 makes 3. 2 plus 3 makes 5. 3 plus 5 makes 8 rather. 3 plus 5 make 8. Then 5 plus 8 make 13. Then 8 plus 13 would give us 21. That is what we call Fibonacci sequence. You may want to find out how it came to be as an origin, but that is what we use here. And we've equated 1 to mean extra extra small, going by the relative sizing of the t-shirt size we saw earlier. Next slide, please. This brings us to what we call planning poker. We'll soon get to the end of this line. I would skip this and we'll take it to the practicals. We'll deal with it more clearly when we are going through the practicals, but it should take some time to go through all these as stated here in this slide as planning poker. Planning poker is a consensus way of arriving at estimates. It's a consensus way of arriving at estimates, where the team will come together and ask themselves, how long do we think it will take to complete a piece of task? And they would all, in a unanimous way, arrive at their points. And they would now review that. When we get to practical, so we'll demonstrate it. There's a tool we use for it. Online, you could check planning pointing poker. There's another planningpoker.com. You could check to see that tool. I would be showing you the physical card we use for it when we get to the practical. Before COVID happened, when we worked at site, we had planning poker at the site, and there were physical cards that we use for planning poker. We'll explain further on this when we get to the practicals. In that true sense, this is one of the tools you would use as a product owner. You will learn to use as a product owner for your estimation. Next slide. We'll see a modification here. I was telling us about Fibonacci sequence the other time. We'll now see this is called modified Fibonacci sequence, and it became modified at this point. 8 plus 13 should give us 21, but that 21 had been modified to 20. After 20, the next number then now became 40. The next number would have been 13 plus 21, which should give us 34, right? 34. Instead of 34, it had been modified to 40. And after 40, under the modified Fibonacci sequence, we have 100. Right? We'll expatiate on those at the practical also. But just note as the difference, there's nothing much there. Just note that we have the Fibonacci sequence, which is the original Fibonacci series, but there we now have a modified one that got adjusted from 21 to 20, then upwards. 2 more slides and we'll be done with this class. In all that we've done so far, we can see in this slide how the product owner makes use of forecasting to or estimation to know the total number of sprints a team would work on a particular product. Let's say, for instance, we want to deliver an epic, and the total epic is 1000 story points, right? If our team velocity is 25 story points, that means in every sprint the team does 25 story points. So the question is, how many sprints will it take us to finish 1000 total story points? So that would then give us 1000 divided by 25, which would give us, what am I doing? 1000 divided by 25 will give us 40, right? I believe I'm correct. Yeah, 40. So from that simple calculation, it means where we have a total of 1000 story points to deliver a particular feature or epic or a particular product, we are looking at 40 sprints to finish the entire project or epic or feature. So this is on the mild way a product owner calculates how long it will take for a team to deliver a total story point. It could be for an epic, a feature, or the product itself. By dividing the total estimate by what the team has capacity to deliver sprint in, sprint out, it will give us the total number of sprints. The next slide quickly, and we'll stop there for this class. In the next class is where we also see what the budget would be like. In the previous example we used, that means where we arrived at 40 sprints to deliver a particular feature, epic, or product. Let's assume it's a product, right? And we arrived at 40 sprints to deliver the entire product. Then the next question is, how much will it cost us? How much will that product, products or epic or feature cost us? What do? We also find out how much will each sprint cost. How much will each sprint cost? Where we have 5 members in a sprint, and each member is paid £1,000, for instance, per sprint. That means we spend £5,000 in a sprint. So how much would then be the total amount for us to finish that particular chunk of work? £5,000 times 40 sprints, and that will give us 20, that should be 200,000, right? But of course we can do the maths also ourselves. yeah, 200,000 pounds to finish the entire product. So that those are on the light mode, how the product owner determines how long it will take for a piece of work to be concluded, and how much it will now cost that piece of work to be delivered also. So this will be the end of this class. It's a long class, but take some time to go over it again. And if you have any questions, please note them down and send them across to me. I'll be glad to expatiate on it. See you in the next class. Bye for now.